Alright, hi everyone. Today I will talk you through the step I took to improve the performance of my stroke classification model and how I assess to refine its fit. The first question is, what did I do to improve the performance of my classifier? And when I started, I trained a basic XG booster classifier on the dataset. However, its initial results were not great, so I made several improvements in this model. The first thing I do is the hyperpattern turning. Instead of using the default setting, I optimize my model by adjusting key hyperpattern parameters. I set the uh, a learning rate lower to 0.01 to improve the learning stability, and max dips set to 3 to prevent overfitting, and the number of its diameter increased to 500 to allow more learning iterations. And I set these to 5 to address class imbalance. This turning was doing to use the grid search cross validation, which help to find the best combination of the parameters. And another things I do is the feature engineering and the processing. And in the BMI columns using the medium, and in the encoded calculable variables, I use label encoding, and I do the standardized numerical features such as the age, level, BMI to ensure the balance weight is across the feature. And the third thing I do is the hide the class imbalance. Since strokes are rare in the dataset, the model initially struggled to predict them. I address these by using scale post weight equals to 5 to give more importance to the stroke cases. And I training on balanced class weight to prevent bias toward the majority class. And also I switch to probability based prediction instead of predict just 0 or 1. I used probabilities, which give better ranking and help in the leaderboard scoring. And the second question is, what did I do to assess or improve the fit of my classifier? After training the model, I need to check how well it performs and ensure it wasn't overfitting or underfitting. Here's what I do. Uh, I use a fivefold cross validation to check the model's performance across different data set of data. This prevent overfitting and ensure the model generalize well. And I use evaluating model metrics. I checked multiple performance metrics, the ROC AUC score. It measures how well the model separated stroke versus non-stroke cases. And I also use the Persistence recall to help analyze how many actual strokes were detected. And the F1 score, it balanced the precision and recall to give a more reliable measure of performance. And I plot a lot of things here, as you can see. Uh, the feature improvements to understand which factor influence stroke prediction the most, the ROC curves to check how well the model distinguish between stroke and non-stroke cases, and this plot to evaluate how well the model detected positive stroke as cases. And also I do the testing on a separate data set. Uh, and the last part, I test the model on unseen test data to see if generates well. The predictions were saved to a CSV file and submitted to the leaderboard and get a pretty good score. So in conclusion, by using the turning hyperparameters, balancing the dataset, and evaluating performance metric, I significantly improved the classifier, and the final achieved on ROC AUC score is 0.872, which is the major boost from my initial version. Uh, if I were to improve the further, I might be explore the stacking model, multiple model, or using the light GBM for even better solution.